Engineers must squeeze a colossal concrete block the height of a 90-story skyscraper into a narrow gap between sheer cliffs above a raging river. The deafening roar of the Choru River echoes against the bare rock. It represents one of the fastest and most violent torrents on Earth. Pure technical recklessness. Experts delivered this exact verdict after reviewing the initial blueprints. The design defies fundamental physics, yet Turkey transformed this deadly canyon into an extreme construction battleground. The Yusufeli Dam. Conquering this wild landscape demands absolute insanity. Standard construction methods fail completely. Heavy machinery takes to the sky. Excavators weighing dozens of tons dangle from steel cables high above the abyss. Steel teeth rip thousands of meters of spiral tunnels straight through solid mountain rock. Then begins the colossal pour. 4 million cubic meters of concrete fill the void. That equals the material volume required to build an entire city from scratch. A mass this immense triggers a violent chemical reaction. The concrete curing process generates tremendous internal heat. Without extreme intervention, the core simply cracks open. Engineers pump massive streams of ice water deep inside the internal piping network. They freeze the monolith from the inside out. Human technological ambition physically overpowers the lethal natural terrain. The pouring stops. The concrete locks deep into the extremely tight rock fissure. To hold this 90-story volume, classic gravity dams proved useless. The V-shaped gorge is too narrow. A standard design fails here. It relies on sheer dead weight. Structures like Three Gorges demand space. Here, concrete logistics would instantly paralyze. The project required a radical compromise. Engineers chose a risky alternative, a double-curvature arch shell. It looks thin. The mechanics change. Water strikes the curved wall. The arc bends under stress. It redirects colossal hydrostatic loads. Pressure vectors shift. Force shoots sideways, straight into solid rock walls. The mountains become active load bearers. Survival depends on pure geometry, not brute mass. The concrete shell climbs skyward, almost 275 meters high, but survival brings extreme vulnerability. The entire structure now relies on the lateral strength of the surrounding peaks, a terrifying gamble considering this specific region of northeastern Turkey remains one of the most volatile tectonic fault zones on the planet. Why risk building a 275-meter arch in a notorious earthquake zone? The answer lies in critical energy vulnerability. Turkey buys nearly 3/4 of its fossil fuels from foreign suppliers. Imported fuels drain the budget. The state demanded total independence. To achieve this, the government turned the fastest flowing river in the country into a strategic weapon. Engineers weaponized the steep valley. The narrow, V-shaped gorge forces the Choru River into a massive pressure chamber, pushing heavy turbines to their absolute mechanical limits. An escalating cascade of numbers justifies this extreme structural risk. 278 cubic meters of water blast through the gates every single second. This kinetic violence generates 10 billion kilowatt hours of power annually, enough raw energy to sustain a massive metropolis. The entire geopolitical gamble exists solely to secure the lives of 2.5 million people. Grand plans for 2.5 million lives could shatter. Will the rock hold a 275-meter arch, or will it crack under pressure, burying the project forever? Engineers begin a tense medical diagnosis. The patient is the mountain itself. Heavy drills bite into the canyon. Diamond tips screech against ancient volcanic rock. Cores emerge. Hundreds of deep boreholes pierce the walls. They map every microscopic flaw. A full three-dimensional geological analysis begins. Data floods into numerical simulation models. Testing starts. The scale is terrifying. Billions of cubic meters of water, pushing outward, crushing the fragile canyon geometry. Microscopic cracks versus massive hydrostatic pressure. Survival hangs by a thread. Everything depends on microscopic structural integrity, zero deviations. The digital models prove successful. Both slopes act as reliable supports. Approval arrives. With the geological diagnosis confirming the structural stability of the rock, engineers finally receive the official green light to launch their brutal physical invasion of the river valley. A deafening roar shatters the valley. Having received geological approval, engineers faced their first physical enemy. To pour the massive foundation, they had to surgically extract the river from the gorge. Forget the pristine digital models. Down here, reality is dirty, dangerous, and violently loud. Every single second, 278 cubic cubic meters of whitewater crash through the canyon. That flow fills an Olympic swimming pool in under 10 seconds. To switch off this natural force, crews execute a brutal invasion. Directed explosions blast straight through solid granite. They carve a bypass tunnel 11 meters wide and 1 kilometer long. It acts as a massive artificial artery. This dark void violently sucks in the white-foamed flow of the Choru River. Claustrophobic dampness fills the air. A low-frequency tremor shakes the ground. The mountain constantly vibrates under extreme fluid pressure. Massive earth-moving machines dump rock into the roaring channel. They build 2 temporary cofferdams upstream and downstream. These barriers isolate a dry working zone right in the middle of the gorge. But the river never surrenders easily. Even with the exposed bedrock looking completely dry, invisible water pressure pushes up from below. Groundwater constantly seeks to breach the newly dug pit. Heavy drilling rigs must eliminate this unseen threat. They grind 50 meters straight down into the solid riverbed. High-pressure pumps inject liquid concrete into the fractured rock. This creates a solid underground seepage curtain. It functions as a colossal invisible shield, deep beneath the surface and as tall as a 15-story building. The grout violently seals all hidden water pathways. The current is locked away. A heavy, deceptive quiet settles over the drained crater, masking the crushing elemental forces pushing against the buried barricades. Weak vertical cliffs would have been a death sentence for the project. To hold the structure, engineers literally stitched the mountain with steel. Natural terrain would collapse instantly. The concrete weighs millions of tons. It rises nearly 300 meters. The bedrock required extreme reinforcement. Heavy rigs bored into the abutments. They drilled tens of meters deep. Workers inserted high-strength steel bars. These formed massive mechanical roots deep inside the dark stone. Fluid injection began. Pumps blasted high-pressure cement grout. Pressure hit 1,000 pounds, the weight of a heavy truck on a coin. A colossal internal bursting force. The slurry shot through the rock. It filled every invisible microcrack. The cement sealed hidden natural faults. It artificially glued the canyon walls. The process permanently transformed the mountain. Fragile rock became solid monolith. Total structural stabilization. Blocks cannot move. Complete rock fusion. Absolute rigid grip. The mountain became the foundation. Now the valley is ready to withstand massive seismic shocks, but access to it is still closed. But the reinforced walls created a new barrier. There is no room for roads on the steep cliffs, so logistics had to be moved into the air. The extreme geometry of the gorge forced engineers into an absurd reality where the construction site operates entirely in 3 dimensions. There is no ground. Steel cableway systems stretch directly between the opposite mountainsides. These aerial transport corridors form a busy skyway designed to lift heavy equipment and loads weighing tens of tons. A massive tracked excavator hovers in the empty void above a 300-meter abyss. Against the colossal rock face, the heavy machinery dangles on tensioned steel threads like a tiny plastic toy. One mistake means disaster. Huge buckets of liquid concrete also glide across this dizzying gap. Every single delivery races against the unyielding laws of chemistry. A fresh concrete mix begins to set and lose its structural integrity in exactly 90 minutes. The clock is merciless. Strict time limits dictated every single movement in the air. Aerial lines moved pinpoint loads. They failed. Continuous supply demanded heavy machines. Engineers bit into solid rock. They faced a geometric paradox. The floor lay deep below, almost 300 meters down. Surface roads meant certain landslides. Calculations demanded a hidden route. They carved a stone corkscrew. It neutralized the deadly drop. The technical gradient ruled everything. 18%, no steeper, no flatter. 2,420 meters of road twist inside the abyss. The mountain acts as casing. Engines roar. Claustrophobic echoes bounce off walls. Massive trucks continuously plunge into the darkness of the stone spiral, feeding the bottom of the gorge with vital resources. The spiral tunnel and aerial cables were operating at their absolute limits, yet hauling 4 million cubic meters of concrete from the outside was physically impossible. How do you supply a megastructure with relentless streams of material when external logistics are completely severed by the sheer walls of a gorge? The project had to become entirely autonomous, cutting off its reliance on the outside world. Engineers designed a radical closed-loop paradox where the construction literally devours the surrounding mountain to build the dam itself. 4 million cubic meters is a staggering volume, roughly enough to pave a continuous 2-lane highway stretching across the ocean from New York to London. Instead of importing supplies, every single fragment of rock excavated from the steep slope cuttings and the deep spiral tunnels was captured for a massive on-site recycling operation. 100% of the blasted mountain debris fed directly into a localized processing chain, transforming a brutal logistical nightmare into an elegant engineering solution. A heavy industrial crushing complex operated relentlessly, filling the canyon with the deafening grind of steel machinery and a perpetual haze of thick rock dust. These crushers shattered massive boulders into precise grades of aggregate, preparing the excavated stone to be reborn as a monolithic structure. From the sprawling storage areas, automated conveyor belts stretching hundreds of meters long carried the pulverized stone directly into the towering silos of a high-capacity central batching plant. The facility mixed the harvested rock with cement, water, and chemical admixtures at a frantic pace, achieving total isolation from volatile external supply chains. Fresh concrete discharged instantly into waiting mixer trucks and heavy aerial buckets, rushing continuously to the launching platform suspended over the abyss. The mountain consumed itself. This localized system allowed the site to remain completely self-sufficient, maintaining an aggressive daily placement schedule without a single interruption from external factors. The gorge echoed with the mechanical heartbeat of a flawless production line, burying the riverbed under thousands of tons of artificial stone. Zero delays. However, this relentless pouring of colossal concrete masses secretly gave birth to a new, entirely invisible threat. Continuous pouring triggered a chemical time bomb. Cement hydration began. Concrete literally kills itself. Water and cement violently react. The mixture generates massive heat. It becomes a trapped volcano. Temperatures spike to 80 degrees Celsius. The outer surface cools fast. The core boils. Thermal stress builds up rapidly. Microscopic cracks tear the mass apart. The structure fractures from within. Load-bearing capacity simply vanishes. Total destruction loomed. Physics became the ultimate enemy. Water meant disaster. A massive industrial ice plant roared. It spat tons of frozen flakes. Engineers entirely replaced liquid water. Crushed ice mixed with raw cement. The boiling core met biting cold. Hydraulic climbing formwork encased the walls. Concrete blocks rose layer by layer. Steel cooling pipes formed a network. Workers embedded them into the cage. These became the artificial veins. Water flowed at 4 degrees Celsius. Circulation ran 24 hours daily. Heat dissipated. The monolith survived. Zero internal fractures remained. An endless stream of ice-cold water continuously flushed through the embedded steel veins to permanently wash away the lethal volcanic heat. But cooling the concrete was only half the battle. The narrow canyon left not a single meter for the main element, forcing engineers to carve a 558 megawatt power plant straight into the rock. The valley offered no flat terrain, pure vertical geometry. Crews had to excavate a gigantic artificial cavern deep inside the solid bedrock of the right bank. This is spatial claustrophobia on an industrial scale. To reach this subterranean fortress, the reservoir flow drops through 3 steel-lined penstocks. They plunge straight down through the mountain. Gravity accelerates the mass. The hydraulic pressure at the bottom reaches terrifying extremes, severely testing the structural limits of the steel. The mountain contains the force. This high-velocity pipeline slams directly into 3 vertical shaft Francis turbines. The kinetic impact violently spins the massive internal rotors, instantly converting pure physical pressure into electrical current. 558 megawatts of raw installed capacity. That output generates 1.88 billion kilowatt hours every single year. One hidden underground facility, 2.5 million consumers. The subterranean complex single-handedly produces enough electricity to power an entire megacity. After shedding its kinetic energy, the turbulent flow continues downward through a secondary tunnel network. It is a completely closed mechanical system spitting the spent water back into the river. Turbine energy means absolutely nothing. The real punch is purely kinetic, 2.1 billion cubic meters. It is ready to topple everything. A colossal heavy water wall. It aggressively presses the dam crest. Static steel anchors hold the line. The water attacks. The structure urgently needs release valves. Massive steel radial gates screech loudly. They pull up. Valves open. A deafening roar violently erupts. The deep sound vibrates the chest. 8,000 cubic meters drop down. Every single second. 3 entire Olympic pools empty instantly. The extreme structural load finally decreases. The main concrete body survives intact. Water roars downward. To handle this apocalyptic pressure, the floodwaters bypass the structure entirely, diverted into 2 underground tunnels blasted directly through the mountain core, each measuring exactly 8.5 meters in diameter. Reaching the final crest elevation of 275 meters was merely the physical beginning of this colossal engineering defense mechanism. To prevent these 8,000 cubic meters per second from tearing the dam's body apart, engineers had to turn the monolith into a living organism with a fiber optic nervous system. When the towering concrete structure finally reached its critical shrinkage point, specialized heavy machinery forcefully injected high-pressure grout directly into the internal contraction joints. This vital mechanical operation aggressively fused individual concrete blocks, each as massive as a cargo ship, into a unified arch capable of withstanding the apocalyptic hydraulic load. The dead stone awoke. Simultaneous with the endless pouring process, technicians permanently embedded thousands of highly sensitive electronic sensors deep inside the cold reinforcement cages, weaving an intricate web of continuous structural surveillance. Temperature probes buried within the brutal mass constantly measure internal heat generation, automatically triggering underground pumps to flush freezing water through an expansive network of cooling pipes to avert fatal thermal fractures. But extreme temperatures are only a fraction of the invisible threats constantly attacking the barrier from within. What happens if a microscopic deformation deep in the core goes unnoticed? A catastrophic breach would inevitably follow, which explains why a regime of paranoid digital control dictates every single second of the structure's existence. To eliminate this critical risk, engineers strategically position displacement devices throughout the entire architecture to continuously register even the most subtle physical vibrations. These sophisticated instruments constantly map out the microscopic, invisible crunch of concrete shrinkage, a hazardous mechanical shift caught only by hypersensitive optics. Rather than relying on heavy bundles of easily degradable traditional wiring, a streamlined matrix of advanced optical threads acts as the primary conduit for this relentless monitoring protocol. Human vision is completely useless against the internal pressures of a megastructure this vast, requiring the network to immediately detect any hidden movements before they manifest into structural collapse. Deep inside the concrete belly, there is no sound of alarm, only the silent transmission of terabytes of critical data racing toward the central control room. Thousands of sensors, underground caverns, and kilometers of cooling pipes converge in one point: absolute control over chaos. Rising 275 meters above the gorge, a concrete wedge the size of a 90-story skyscraper locks the chaotic power of nature into strict infrastructure parameters. It is pure dominance. Pouring millions of cubic meters of concrete into a harsh, unpredictable canyon demanded ruthless structural solutions. Engineers shattered solid mountains to divert the torrential currents. Gigantic steel anchors bolted the megastructure directly into the rock faces. Internal circuits cooled the artificial stone. Zero room for error. The ultimate triumph of the Yusufeli project transcends its towering dimensions. By generating over 500 megawatts of power, the dam physically overwrites regional energy vulnerability. It neutralizes devastating floods and sustains millions of people for decades. Nature no longer rules here. Modern engineering imposes its own rigid order on the landscape, permanently dictating terms to brutal rock and crushing water.